Hello.
It's us again.
It's us again.
Look at it. Look at it.
Welcome to You Choose. Welcome to You Choose, our choose your own adventure style show where we're going to go through the whole CNCF landscape. And this is the first episode of Chapter 3.
We're not going to go through the whole landscape today.
No, today. Buckle in.
No.
Yeah, it's a marathon. Now today, what are we gonna go over today, Victor?
We're going to go through admission controllers in Kubernetes, policies, validations, mutations, all that jazz. We have a record number of projects. We never had, what do we have? 5, I think?
We
never had 5 projects in one category. So it's going to be fun. We're going to find out what it is, how it works, and stuff like that, and all that in 5 minutes each.
5 minutes each. And let's give some context up top about admission controller policies, because as I get into learning more and more about security just seems to have a lot to do with policies all over the place. So what does it mean to be an admission controller policy?
What it means is that when you submit something to Kubernetes, and there are people who know better than me, so they might correct me later, right? But you submit something to Kubernetes, some desired state, and then you can have you can configure webhooks that will notify some processes in order to do something with it, right? One thing you can do is to validate: is this valid? Can this be applied in the first place? Should we modify it? Should we mutate it at something? There are other types of admission controllers, webhooks, but I think that today we are going to be focusing mostly on those, on validations and maybe a bit of mutation as well.
So with most of these technologies, when you make a policy, the first thing that happens is a webhook gets created. So what that means is extra configuration is given to the Kube API server. That's telling the Kube API server, when you see this object paired with this action, then you need to send it somewhere. And then the place you send it to is the admission controller, which is a piece of software that's running, that's going to evaluate whether it gets made in the case of a validating admission controller or whether it gets mutated in the case of a mutating one. But for new people like me, this admission controller can also be called a policy server or a policy engine. It's all the same piece of software, right? Yeah? Yeah.
Yeah, depends. It
depends. Always
nothing
depends.
exists in this industry until it has at least 15 names. Until then, it's experimental until that point.
And then it makes it really hard for new people like me to figure it out. But so that's the model we're working with here today, except for one project.
If it would be so easy to figure out, then me and a bunch of other people in this industry would lose jobs. So it's very important that it stays complicated.
So let me think of a fourth name to give that piece of software. So as the format of the show, for those of you who are new here, is that we have 5 projects on. Each person who's here to represent a project gets 5 minutes to teach about their project. And we love cutting them off. Victor loves cutting them off. And so no longer than 5 minutes, because the idea is we want them to give a high-level overview and not dig into the details too much. And then after that, we'll have a Q&A part to the show. And then after that, we'll put it to a vote. And you, the community, you get to choose which project you want to see implemented in our ongoing demo. So this is not a win-lose situation. The project that gets chosen is not at all the best project. These are all wonderful projects, but the idea is just which one do you want to learn more about and see implemented. And to that end, we have so one thing that y'all were telling us is that you don't love that the vote's on Twitter, which I agree with. Twitter's not that great these days.
There is no Twitter anymore. It's X.
Oh yeah, even that. I can't handle it. I'm in denial still. So we're going to try something new. Tell us what you think. We're going to try doing our poll, do the vote in the CNCF Slack workspace, we've made a channel, a You Choose channel, you-choose. And I believe, Victor, you have a short link to our You Choose channel. Maybe you
Yeah,
put that up there.
I'll put it on a screen and in a chat later when we get to the voting. I don't want people to come to
Don't leave
conclusions
us.
too early. Yes. Yeah.
Well, I'm not going to put the poll live until the end of the show. So
Then
y'all
I can
can't
put
vote
it on a
until-
screen.
Yeah.
Maybe.
So
We'll
you
see.
can find it on your own, but also we have a short link for you to get to it. So let us know what you think about this new way of voting. I think it's super cool. It also puts you in the CNCF Slack. So then if you have questions for any of these projects, you can either put them in the You Choose channel, or each of these projects will probably have their own channel where you can ask questions about the tool. So we're doing that differently this time around, and would love to hear your feedback. When you have some, not yet. It's too soon. You have to try it. And with that, let me ask you one more thing before we move on to our guests. And that is, like, what should we be looking at when we're evaluating all these different tools that can do admission controller policies?
I mean, there are quite depends really who you are, right? Some people will look into different ways to define those. Some people like YAML, other people like, I don't know, JavaScript, right, to define policies. They will look at the feature sets, what all those engines can and cannot do, and probably a few other things, right?
What are some example of feature sets?
Feature sets, for example, there are typical ones that everybody has, like, hey, you can use policies to say yes or no to validity of something, right? Kind of, this is valid, this is not valid. You have policies, most of the tools also can mutate. Hey, you gave me this, but I'm going to sneakily change it to something else because you don't know what you're doing. But then there are additional things like, hey, can we validate, for example, against SIG-Store whether this image is signed, right? That's a bit going beyond simply validating the manifest, the specification of something as is, but also going somewhere else, comparing it with something, things like that. So this is just one example, right? There are many others, but I think that basics are, it's wrong to say basics, right? Most of the tools are on a similar base level, and then some of them are differentiating from others in those additional things that they can do, right? Besides different way of operating them to begin with.
So really a big thing we're looking at is what language the policy is written in. That's going to vary between each of these tools.
Whether it is only for Kubernetes or also beyond, and additional things.
Okay. And
I don't want to put too many spoilers from the talks that we're going to get now.
Fair enough. And so just an example of a validating policy might be like if there's no compute limit set, then we're going to say, no, you're not allowed to create this pod. But you could have that same thing as a mutating policy where if there's no compute limit set, edit the thing and add a compute and then let it through.
Exactly. It depends what your goal is, right? Is your goal to add stuff that people should not necessarily think about, right? Like you can say, hey, my company, people don't need to worry about resource limits. I'm using it as example. I'm going to edit it myself. That will be mutation, right? Or you can say, I want to educate people that if they don't put it, that they should put it, but I'm going to, through the policies, tell them, hey, you forgot to do this, right? I tend to see policies, and this might be only me, not as ways to prevent people from doing the things, right? Not as acting as a barrier, as a policeman, but more like educational, right? With policies, we can guide people towards doing the right thing. My perspective. So again, right, kind of different projects might have different perspectives on that, but to me, policies are guidance more than anything else.
Amazing. Are we ready to introduce our guests?
No.
No? Okay. We'll wait backstage.
No, I like confusing you. Just
put on some elevator music. I'll just sit here, stare at you, smile. I'm cool.
Okay, let's do it. I see that.
All right. Up first, we have Tim Bannister. Tim, hello. Introduce yourself, please.
Great, sure. So I'm a senior consultant at the Scale Factory. We are an award-winning software as a services consultancy that helps businesses who really use the AWS cloud, and some of them use Kubernetes. And apart from the day job, I am a technical lead for Kubernetes documentation. So the documentation special interest group in Kubernetes, I am one of the leads. I will be stepping down later in this year, but right now I'm still a technical lead for the documentation. And
Amazing.
so I learn about things by checking if I understand them, and if I don't understand the docs, I send them back to the people who implemented the feature and say, this doesn't make sense to me. So you're going to have to explain it better.
The power. You're the litmus test.
One off.
Amazing. Well, thanks for introducing yourself. We'll see you again shortly, where you're going to teach us about Kubernetes validating admission policy.
Sure.
See you again soon. Bye, Tim. All right, next up we have Rita. Welcome, Rita. Thank you for representing OPA Gatekeeper today. Will you introduce yourself, please?
Sure. My name is Rita. I am a software engineer at Microsoft. I'm one of the maintainers on OPA Gatekeeper. I'm also a Kubernetes contributor, a SIG auth chair, and I'm on the Kubernetes Security Response Committee to report all the CVEs that you guys get. So nice to see y'all.
Awesome. So nice to meet you. Thank you so much for sharing your time with us today. Bye. All right, Kevin's up next. Greetings, Kevin. Hello. Introduce yourself, please.
Hi, I am Kevin. In my day job, I'm a capacity SRE for the Elastic Cloud Service. That means that my team and I are dealing with things like how much are you spending? How much capacity do we need to serve customer workloads? And as part of that, we use Cloud Custodian, which I'll be talking about today. And
Excellent.
when I'm not doing that, I have a podcast, I have chickens, we do all kinds of fun things. So that's me.
It's a varied existence. So nice. It's so nice of you to be here. Thank you so much for being here, Kevin.
Not many people can put in a same sentence, I have a podcast and chicken, and be casual about it and just move on.
It's
That
what I
doesn't
do.
happen often.
SRE podcast chickens. All right. Bye, Kevin. Next up, we have Jim Bugwadia. Hello, Jim. Welcome. Introduce yourself, please.
Hey everyone, I'm Jim Bugwadia, co-founder, CEO at Nirmata, also a maintainer of Kyverno, and a co-chair in the policy working group in the CNCF. Pleasure to be here.
Awesome. Thank you so much. And we'll see you again when it's time to talk about Kyverno. Bye. And then last but not least, we have Flavio. Welcome, Flavio. Introduce yourself, please.
Hi, everybody. I'm Flavio Castelli. I work at SUSE inside the Renter division. I'm a distinguished engineer over there, and I'm one of the maintainers of the Kubewarden project.
Amazing. I can't wait to hear more about it. Thank you so much. I'll see you again shortly. All right, so we're going to start by talking about Kubernetes validating admission policy. And so we're going to bring Tim on first. But before we bring him on, I want to say, when you have questions, please do ask those questions in the chat. We're not going to get to them while Tim's talking. He gets his full 5 minutes to say whatever he wants. But later we'll have a Q&A part of the episode, and that's when we'll dig in on all these questions. So please do ask them right away. But we're going to ignore them for a while.
If history repeats in this case, we are going to have more questions than we can answer. Mm-hmm. So the sooner you ask, the bigger the chance that it will be answered.
And
live.
if we don't get to your question live, please do ask it in the You Choose channel in the CNCF Slack workspace, and we'll get to it there. All right, Tim, we're going to bring you on, and then Victor will count you down for when your time starts. He gets very excited about this part.
It starts now.
So, in Kubernetes, I'm going to build on what Victor talked about around admission controller when it happens. So, there's you, the user, and you're trying to do something to Kubernetes, like delete a config map, or remove a limit range, or change one key in a config map. And the Kubernetes API server is going to decide whether that happens or not. And there's a lot of complexity in what sounds like a simple thing. It's like, well, I want to make my change. So first of all, we don't know who you are. Is this an anonymous request? Well, we're going to have to authenticate you. And that's happened. And then we're going to have to see if you're authorized to make the change. And there's a whole other talk on authorization, and you can use webhooks for that. But that's happened. We've done it. We know who you are, and we know that you're authorized to make the change. But we still don't know if you can make the change that you want to make. Like maybe you're trying to, change one key in a config map, which is probably okay. But maybe you're trying to change one marklar in a config map. And here's a problem. The marklar API, there's no marklar in a config map, so you can't do that. Maybe you're trying to do something to a custom resource that's defined with a custom resource definition, and that custom resource definition has its own rules about what changes you can make, and you haven't passed those rules, so that can't happen. Oh, no, there's a problem. But if you passed all of that stuff, there's more. Wait, there's more. Kubernetes has all of these admission control mechanisms to either change what you were going to do, like you thought you were changing the username to Whitney, but you're not. You're changing it to Victor because a mutating admission controller has said, no, we prefer the username Victor. And that could happen. Someone could do that. We could demo that. And even then, after we've done the mutating changes at admission control time, there's more. We can do validating checks. And that's where we could do like a validating check within the Kubernetes API itself. We don't have to have any of those webhooks. We could use a validating admission policy. And so a validating admission policy, can I have my slides up?
Absolutely.
Cool. Here is some documentation I prepared earlier. Validating admission policy, I didn't write this, I reviewed it. Here is some documentation, and you can see like a bit of YAML. So if you like YAML, this is your friend. And especially if you like YAML that embeds Google's CEL language, because that's the one we're using. You can use a validating admission policy to define just validation checks. You can't do mutation with this. You can't change Whitney to Victor or Victor to Whitney. It's not going to happen. But what you can do is say, yeah, I only want 5 or fewer replicas of this pod. You can say, I don't want to have a field called password in my config maps. Or actually what you can do is say, yeah, you can have a field called password in your config maps, but you're going to get a warning from kubectl when you try, and it'll come back in yellow on your console, and it'll show up in your CI/CD pipeline as, this job produced warnings, because Kubernetes lets you do that. And a lot of the other options that do work with webhooks, they let you do warnings as well. So why would you do this? Well, it's beta, but when it graduates, one of the incredibly useful things you can do is to protect one of the other options that you're going to hear about. Because when you run a webhook system, one of the things you can do as a cluster operator is make a big mistake and not run the webhook properly, and now you can't do things. And if you had a security policy that said, oh, we can't run pods unless Gatekeeper says okay, or Kyverno is happy with it, here's a problem. You can't start that new Kyverno pod, or you can't start that new Gatekeeper pod. Maybe Cloud Custodian is not very happy either, because the policy engine isn't working anymore. And how are we going to fix that? Well, maybe we say that actually the policy engine doesn't check itself. And that means we need another mechanism. Let's call it validating admission policy. And that's what I recommend we use for that. So whether we use it in this demo, that is what you should use in your real clusters once this graduates to stable. Thanks.
Awesome. Cool.
That's it.
Thank you.
Didn't flow over the 5 minutes. I'm disappointed.
No. Sorry.
Don't bring him again.
Next speaker.
You did too good of a job. Thank you so much. We're going to bring on Kevin Sonney next. All right. Thank you, Tim. We'll see you for Q&A later. All right, Kevin. Bring you on. Would you like your screen shared right away?
No, not right away.
Okay, cool.
I want to just a brief on Cloud Custodian first. For those who don't know, Cloud Custodian is, yes, you held up your finger. So,
Victor's clock. I just want to make sure the time
No, my
started.
clock is running. I don't know what you're talking about, but it's running.
It's fine. It's fine. Cloud Custodian is a lovely bit of Python that lets you validate or change or even go so far as to stop things in your cloud environment. And that includes Kubernetes. So you can actually use it to look at instances. You can use it to look at VPCs. You can use it to look at clusters or deployed workloads on your Kubernetes. It also supports, yes, using it as a controller. Now, in this case, it's a mutating webhook because it can do both make the changes and say, oh, this is allowed to launch, this is not allowed to launch. So now if we can share, we can just do a quick look at a webhook. Like this is a very straightforward webhook setup, right? And this would set it up to work as a standalone application. And there's documentation on the custodian site to do that. You can also deploy it as, hey, look at this, a Helm chart or whatever kind of deployment you're using, and run it inside of Kubernetes itself. I kind of like that option, right? As with all of the custodian functionality, it's configured using very straightforward YAML. And so you can just say, hey, when something is being created or updated, in a very simple example, I'm going to send a warning. Just send a message that says, hey, we created a thing. You can get even fancier with it. For example, we have a tagging policy in place, and you are required to have tags. So, hey, if you match any of the filters, right? If you don't have, say, an app label and it's part of this particular value set, you're going to get denied. If this one actually says, yeah, if not or. So you have a logical language that goes into it, so you can do really complicated admission policies. And because it's a mutating webhook, maybe we say, oh, if it's like if your team is absent, let's set that for you based on additional metadata. Or if your project is absent, we can put in a placeholder. So all of these are options for you, and it makes it really simple. And as we saw with our Helm chart over here, it can be stored when it's running as its own pod in a config map. So it's always there, it's always ready. You don't have to worry about mounted volumes or any of that sort of thing. The one warning I will say is when you set up your policies, you probably want to put in a check to say, hey, is this my custodian policy? Or you can find yourself, as I did earlier, verifying a couple of things. You will not be able to update your pod. So, so as with all of these, you want to be really careful and make sure that, hey, the policy for the controller that's going into place doesn't actually exclude the controller in this particular case. So that is it for me. Sorry, Victor.
Oh, Victor, they have your number today.
No gong. No gong. Somebody will fail. I know it.
Thank you so much, Kevin. And we'll see you for the question and answer section later. All right. Rita is up next. Welcome again, Rita.
Hey.
Please. Yeah?
Yeah, let's
begin.
share the screen for Gatekeeper real quick.
Absolutely.
All right, so Gatekeeper project is a customizable multi-engine Kubernetes admission webhook, helps enforce policies and strengthen governance, and it comes with a CLI for shift-left validation. The project started back in 2018 and has since been integrated into and offered as managed feature by a lot of the major Kubernetes managed services like AKS, GKE, etc. The project has maintainers and contributors from all major cloud vendors, and it has proven stability and scalability, supporting large cluster scenarios, making it an ideal choice for enterprises. When the project started in 2018, we started the Kubernetes Policy Admission Controller with OPA as the root engine due to its wide adoption and its ability to handle very complex policies across different tech stacks. So maybe just a real quick intro. What is OPA, right? OPA project started in 2016. It's a general purpose policy engine aimed at unifying policy enforcement across different technologies. It handles very complex policies without requiring you to query going to an external system for processing. Today, OPA is used by many companies. It was accepted to CNCF in 2018, and now it's a graduated project since 2021. And much like Kubernetes, the OPA community is very welcoming and vendor neutral. And a lot of contributors have been driving the growth and the integrations and adoptions that we're seeing. So maybe just real quick, what motivates the project? What's our goal? Again, I'm just going to list these, right? Like other solutions that you're seeing, all the policy admission controllers share the same motivation, right? To help the end users control what they can do on the cluster. And Gatekeeper is no different. The project wants to ensure conformance without losing agility and autonomy, and being able to help policy writers to write the policy once and use it anywhere, whether it's in their deployment time or in their CI/CD, right? Another motivation that we have learned throughout the last few years with the project, learning from our users and running Gatekeeper in production, is we continue to see the space evolve. And we realize that we need to reduce the policy fragmentation and improve the user experience. And we believe Gatekeeper can be the front end, the abstraction layer that provides the multi-language, multi-engine, multi-target policy enforcement that allows portable policies and allowing us to coexist, the different policy implementations to coexist. And we recognize the drawbacks of admission webhooks, as we talked about that earlier, right? Which is actually why we have been contributing to VAP, short for Validating Admission Policy in Kubernetes Core, and bring a lot of the learnings from Gatekeeper. And the same Gatekeeper concepts are actually part of the design inspiration for a Validating Admission Policy feature. And now it's supported in Kubernetes entry. And we believe that for many simple scenarios, let me just quickly move on. And we believe that for many of the simple scenarios, we do think that using VAP makes a lot more sense to reduce admission request latency and improve reliability and availability. But for non-VAP scenarios, and I think someone was asking in the chat, things like audit, referential policies, external data, mutation, those continue to be scenarios that require admission webhooks. And for that, this is exactly why we added multi-engine support in Gatekeeper to allow users to write policy in the language of their choice. And what that means is OPA Rego for complex policies, VAP Cell for simple policies, and again, give the project the ability to grow as a technology and the community is growing. So let's look at the features, right? Again, we're no different than other webhooks in terms of validating and mutating. We have audit, we have PubSub for you to allow you to subscribe to different audit results. And again, referential when you want to do compare new admission versus resources that's already in the cluster, like unique ingress host. And Gator for you to test in your CI/CD for shift left validations and actually be able to preview the policies before they're actually enforced in the cluster. And that's the dry run and warning. And again, external data. And last but not least, we also have a community policy library.
No more.
Thank you.
5 minutes. I did it. Now I'm happy. Thank you, Rita. You're muted, Whitney.
Thank you so much for bringing Victor so much joy, Rita. And we'll see you soon for questions. Bye. All right. Next up, we have Jim.
Yeah.
Welcome. And Jim, Jim's going to share your screen, I believe.
Yes, let me share.
Okay. Here we go.
All right, so just real quick, I'll start off with some history on Kyverno and why we created it. So the first motivation was as we had looked at the landscape, and Kyverno came about 2 years after Gatekeeper. So as we look at the landscape, the number one complaint we heard is complexity, right? So really trying to make policies very simple to use, simple to define and manage for Kubernetes admins, not for other systems or tools which were integrating policies. And since then, as we've kind of, evolved, we also have added not just mutation, but also several use cases to generate resources, really address the full life cycle of configuration management using policies in Kubernetes, right? So maybe looking at the top, what I feel are the top 10 features in Kyverno today, and we'll talk about how it's evolving. So first off, like we said, starting out with very low code, no code policies, and then being able to use James Path, and also we've added in the latest release support for cell as well as validating admission policies. Being able to validate, mutate, generate, clean up, so full lifecycle management of resources in Kubernetes, which becomes extremely important if you're solving bigger problems with policies like multi-tenancy, etc. Integrated image verification with both cosign and notary, API calls and extensions. So, just like Rita was mentioning, even with Kyverno, if you want to write some, policy in Python, now we have support where you can call an extension which executes Python and returns back a result, right? So very extensible and easy. From the beginning, we've had integrated unit tests, end-to-end testing, which is one of the new tools we have introduced. CLI also for offline validation, things like that. Kubernetes native, so not just policies are Kubernetes resources, but reporting is native in Kyverno as well as managing policy exceptions. So really thinking of full self-service, full lifecycle, and then paying a lot of attention to making it easier to manage webhooks at scale, as well as one of the newest features we added in 1.11 is auto generation and auto management of validating admission policies, which based on time and at the risk of being gonged, I'll try and do a quick demo. But before going to that, just talking a little bit about also how Kyverno is evolving, what's our philosophy, and where do we see things going. So from Kyverno, also we have, kind of brought a policy reporting API. So we want reports to be native in Kubernetes. We want, and one of the things we heard back from our community was, hey, Kyverno is great, but I also want to apply policies maybe to Terraform, or I want to apply policies to my Docker file. And for that, we've introduced Kyverno JSON, which lets you run Kyverno outside of Kubernetes when you need it. And one new sub-project that we have also launched is Kyverno Chainsaw, which does declarative end-to-end testing using Kyverno as the underlying format, right? So with that, let me just quickly screen share. And, I have a cluster here. And what I'm going to do, I have a few policies installed, but I'm going to create, a namespace here as a user. So let's say I'm going to create a namespace test as Nancy. And as you see, Kyverno blocks that immediately, right? But what I want to now do is I'll create a valid namespace, and I have a resource for this already. So I'm going to actually pick the right resource. And this is allowed. Now, the nice thing is if I look at the namespace, what happened over here is underneath, Kyverno automatically generated things like, quotas, network policies, role bindings, everything for that user. So that named user has full control. And if I try to access this namespace as a different user, I'm immediately blocked, right? So very simple example of a powerful set of policies. And one other thing I want to quickly show is, the new validating admission support, right? So if I just do service accounts here, which is another set of policies. Now, these are simpler checks which we can run, in Kubernetes using validation admission policies. But the nice thing is once I've installed this, and if I do get validating admission policy, I see these automatically generated. And if I do reporting, I'll automatically see Kyverno also generated reports for these. So perfect timing. With that, I'll stop sharing. And
Thank you so much.
Victor's happy again.
I'm happy again, exactly.
I'm happy too, to be honest. I can tell it's close to time because I see Victor get a grin on his face at about 20 seconds out. That was a wonderful presentation. I really appreciate you sharing your time with us. And we have one more and then question answer. So thank you so much, Jim, and we'll see you on the other side. All right, Flavio. welcome. Let me
Hi.
let's remove this Kyverno banner. All right, and we're going to share your screen and get you started. Here you go.
Okay, thank you. So Kubewarden is a CNCF project. It's a sort of sandbox right now. It started as a policy engine for Kubernetes, but recently we allow to use Kubewarden also outside of Kubernetes. So we can validate basically any kind of JSON data that user wants to go through, like it was mentioned before, like Terraform files or any other kind of thing. But the main focus remains, within Kubernetes. So in terms of validation, we can, of course, do the usual validation, so accept or deny. We can also do mutation. And in both cases, we can also leverage information coming from within the cluster. So things like what are the other ingress objects that are already being defined inside of it. Or we can use information coming from external sources, which could be, I don't know, container registries, a SIG store, or many other types of information. All of that is used by the policy, can be used by a policy to take a decision, to accept, reject, or mutate. When it comes to writing policies, we allow basically a lot of flexibility. We started by focusing on traditional programming languages. We provide SDKs to write policies using Go, Rust, C#, and other languages can be added depending on, the request coming from the community. But in certain cases, it's better, to use like a smaller language, like a domain-specific language. So we support Rego, which is used also by Gatekeeper, as was mentioned before. And we do that without requiring any change to the original policy written in Rego. We have recently introduced an experimental way to run some types of Kyverno policies to use, the DSL that they leverage to write policies. And we're going to support Cell. There is some work in progress about that, which is the language that was described before, the one that is now going to be supported by Kubernetes in a native fashion. How is that done? This is done because all our policies, they are basically written in these programming languages, and then they are compiled into WebAssembly, which is this new fancy technology that you might have heard about. The way you see that is like you start from some source code and you run it through a compiler and you obtain this binary blob, which is this WebAssembly module. This is a portable computational unit that can be run everywhere. There's no need to rebuild the policy, so you can run it on any kind of operating system or architecture that you have. The policies, they have a really small footprint. The evaluation time is really fast, and they are also run inside of the sandbox, which makes the code isolated from the other parts of your system, so more secure. The cool thing when using a traditional programming language is that you can reuse your existing knowledge. You can use libraries from this programming language ecosystem, linters, tools that you're already familiar with. So yeah. Once the policy is compiled into WebAssembly module, you of course want to run that on top of your cluster. So after having deployed the Kubewarden stack, what you're going to do is to consume these policies. These policies are hosted on regular container registries, the same container registries that you use to host your container images. And that's because they are stored over there as OCI artifacts. We have a tooling that simplifies, the process of management of pushing the policies, and the pool is done automatically. And we can reuse all the procedures and processes that you have in place when it comes to, signing images. You use the same set of tools also to sign and to verify the policies. Of course, we have custom resource definition that you use to, declare the policies that have to be enforced in the cluster. You can run them in different ways, like in a warning mode or in enforcement mode. And you can then leverage, things like our audit scanner that gives back, reports about what is compliant and what is not compliant to the cluster. And that would be it. I try to stay light, so to not incur into the ringing bell.
Brilliant.
Great job, Flavio. Thank you so much. So we have tons of questions to get to. Victor, will you take the Kubewarden URL off the
Will it
screen,
take what?
please? The Kubewarden URL off of the screen while I bring
Oh,
on all
yeah.
of our guests. Yeah.
Yes. There we go.
I accidentally brought. There we go. Here's everyone. Hello, welcome back. Thank you all. I'm going to get into the questions. The first question we have is for validating admission policy, which people have been saying VAP when they mean validating admission policy. So what can VAP do and what can it not do compared to the other policy agents? Tim, that's a question for you.
Yeah, sure. This validates one change to your cluster. So it doesn't look at anything else in your cluster other than the things it's changing and the policy rules you put in place. A key thing I want to say is that none of these things, if you're doing an admission controller, none of these things are fixing your existing objects. So if you put a thing saying, I'm going to ban config maps called Tim, you can still, if you've got a config map called Tim in 4 of your namespaces, it's still there. And some of these engines will be like, okay, we're not just an admission control engine, we also go and delete those objects for you. But that is not admission control, that's like more like a traditional controller that says, we're not having these, so, bang. So it won't deal with your existing objects, and it won't say things like, hey, you can't have a blue deployment and a green deployment at the same time, because it doesn't know that. You are looking at one object, one thing coming in. A blue thing is coming in, and either the name blue is allowed or it's not allowed, but it doesn't know that there's a green at the same time.
So it doesn't mutate, and then it doesn't have context.
Yeah, exactly.
Okay. Excellent.
And it doesn't fix what's there.
And it doesn't fix what's there. Yeah, which is mutating maybe, yeah?
Oh, no. So
question that is,
mutating is not fixing what's there. Fixing what's there is saying,
it's just more like
if you
watching.
put a policy in, the stuff that's already gone past admission has like, that happened. It admitted a month ago before you thought of the policy.
Got it. What were you saying, Victor?
I have a question that is not really, more on a Kubernetes level or admission policies. Is there any attempt to somehow have admission policies that kind of take multiple resources in?
Well, each HTTP request is a thing. Like, I mean, people have talked about how will we do transactions in Kubernetes, and then the people who looked at it went, I'm not sure we have the level of volunteers looking to, add transactions into this thing. It's already pretty complicated. So this is not the stream to talk about putting transactions into Kubernetes, and that's what you need. You need the whole batch of things to go in or not.
And then we have a lot of chatter around validating admission and policy. When is it going to come out? When will it be GA'd? And then is it optional?
So I'll tell you what you have to do right now, because a lot of people don't realize that beta APIs are off by default. This wasn't what happened in Kubernetes 1.0. We changed the policy during the project. So if you want to use this, you have to do two things. You have to turn on a feature gate, and you have to enable the API group, admissionregistration.k8.io/v1beta1. You do if you do those two things, you can use it in beta. Will it graduate to stable in v1.30? Quite likely, I think, but don't quote me on that. Will it graduate to stable eventually? Almost certainly. There's just so many benefits to having it that the motivation is there. People on this call work in contexts that are working with validating admission policy. We heard that from the other people. So I think it's really likely. It's never going to be a CRD because it doesn't really make sense to add this as a CRD to your cluster and re-implement it when the API server is going to do it for you.
Excellent. Thank you so much. Hopefully that clears up all the chatter, but if any of y'all want to know more about it, ask another question. Next one we have is about Cloud Custodian. So Kevin, this is for you. How does Cloud Custodian work with non-Kubernetes environments? Where and how does it run?
So working with non-Kubernetes environments, it goes straight to the API and makes API calls using the Python SDKs. Where and how does it run? In our case, we actually run the container version as a Kubernetes cron job that mounts all of our credentials as secrets, that then mounts our policy, our YAML policy files off of the config map, and we run it once a day is pretty much how we do it. There are a whole bunch of different ways to do it. And if you check out the custodian, the Cloud Custodian Slack, or the discussions around it in GitHub and the website, you can see a whole bunch of examples. Ours is a reasonably unique case because we're looking at multiple, and by multiple, I mean well over 100 different accounts across all 3 major CSPs.
Excellent. Thank you so much. Next question is from Sebastian, and it's for Rita. Sebastian always gets confused with OPA and Gatekeeper. Is Gatekeeper a Kubernetes wrapper for OPA or something separate using Rego?
That's a good question. And we were just talking about how the project started as a admission webhook, and OPA was the original, the first rule engine that we supported. So yes, it is a wrapper for OPA rule engine. However, since then we've added the ability to add additional rule engines like validating admission policy. So now you can actually write Rego policies as rules. You can write for complicated policies, or you can write cell-based rules and for simple policies.
That's great. And then a follow-up question to that is, would it ever make sense to use OPA in Kubernetes without Gatekeeper?
Yes, and I think in the chat we also mentioned there. So the OPA project also has another sub-project called Kube Management, which precedes Gatekeeper, and in fact it existed before Gatekeeper. So ever since we had the Gatekeeper, we've added a lot of new features like audit, external data, referential policies, mutation, a lot of new features that that we've been adding to Gatekeeper, but not necessarily in Kube Management. So yes, you could use Gatekeeper with Kubernetes without. You can use OPA in Kubernetes without Gatekeeper. However, if you want to get the benefits from Gatekeeper, you would need to use that.
Okay, so it doesn't really make sense to do it without Gatekeeper.
For some simple scenarios, for OPA, you could. Again, you can always do it, but should you is a different question.
Excellent. Flavio, the next one's for you. It's why use WASM if they're still packed with the WASM runtime in the OCI containers?
I don't get the question. So,
can just ask, what's the benefit of running policy using WASM modules?
Inside containers. I guess that's the question.
No, they're not inside containers. So container registries are just a way to move around the binary blobs that are WebAssembly modules. So they are not inside of it. The module is like maybe 100 kilobytes and 1 megabyte top, and there is just the business logic of your program inside of it. There is no operating system, nothing at all. It's just a way to move around this function. You can see them as function as a service from a certain point of view.
Okay. And does that explain what the benefit of using WASM?
And the benefit of using WASM is to be able to use any programming language that can be compiled into WASM to write your policy.
Excellent. And then, Jim, this one's a general question, but I'm going to send it your way. Can and should you run multiple policy agents at the same time?
So you can, but it's questionable if you should, right? Because like we were discussing earlier, running an admission controller does require careful management. You want to make sure it's an HA workload, it's properly configured, and it's responsive and scales well as well, right? So now, of course, if you're running multiple policy engines, you have to kind of duplicate that effort across. But what we see as the space is evolving, and as you probably saw from the presentations, it's very likely you're going to be running validating admission policy as the first line of defense, and then something like Kyverno or Gatekeeper as the second line for additional policies for other use cases like mutation, generation, cleanup, etc.
Excellent. Thank you. And then for you, Flavio, again, do you need to have WASM runtime installed on your cluster nodes with Kubewarden?
No. Kubewarden comes with a component called Policy Server. This is where all the policies are scheduled, and this is running as a regular pod inside of your cluster. And this is where the WebAssembly engine is running.
Excellent. And then I have a question that is for everyone. I'm going to start with Rita because it mentions OPA specifically. So from Bill, it says, I think OPA can draw data from external sources while making decisions. Can the others also, so I guess, Rita, will you please validate this? And then the others, the question is, can your tool draw on external data sources at decision-making time? So Rita, is it true that OPA can draw from external sources while making decisions?
Yes. And if you want to try it out, there's an external data feature that allows anyone to create a plugin that allows Gatekeeper to talk to the external data source and be able to expose it as part of the policy rules. And then OPA will be able to evaluate the data from that external data source.
Okay, excellent, thank you. Kevin, can Cloud Custodian draw from external sources while making decisions?
Not really. It's looking at that policy file. And so once it loads the policy file, it kind of uses just that policy file. Now, that doesn't mean you can't update the policy file or have a trigger that when you update the config map, it'll restart the pod. But it's not looking at databases or anything like that.
Okay. And then
can you run, additional question from my side. When you run inside Kubernetes, the custodian policies, can you use non-Kubernetes policies or only Kubernetes ones? Can you use AWS or that's reserved for outside?
I mean, if you're running as an admissions controller, that's specifically going to look at, just handle those webhooks. If you're running inside of Kubernetes and you want to have another setup of a custodian pod that does all the other enforcement, sure, as long as you've got the right credentials. I mean, it comes down to credentials and access at that point.
Sorry, Whitney, continue.
No, it's all right. Tim, I feel like we may perhaps already talked about this, but is validating admission policy able to pull from external data sources?
Can I get my screen share up? So the short answer is...
That's dangerously close to extending your presentation. I don't know. It's
well, the short answer is no, and the longer answer is it's complicated.
Oh, you were under 5 minutes.
Can I have my 4 seconds back?
No. I wanted to say he used his 5 minutes to explain what admission controllers are beyond validating policies. So he gets extra credit. Yeah?
Okay.
Cool. So you can set a parameters thing. So in this thing that I've got on screen, we're setting some params.max replicas. And where does that params come from? It comes from another API, which you'd think, that's going to be a custom resource definition, right? I have to make some sort of replica limit CRD and define it. And then I have to not just define the CRD, but I have to go and put some replica limit in the right namespace. And then that's going to work. Sure. And for beta, you have to use a CRD. You can't use the other way of doing API extensions, which is the aggregation layer and API service. But for stable, who knows? We haven't implemented it yet. So watch this space, because the complicated answer is maybe you will be able to do that by the time this feature is completely finished.
Wow, so exciting. Jim, you're next. Can Kyverno draw from external sources while making decisions?
Yes. So with the API extension features, you can delegate, decisions as well as, pull data from any external source. Now, of course, during admission controls, whether you want to do that is questionable again because of latency, things like that. So that has to be kept in mind, but it's completely possible.
Excellent. And then last but not least, Flavio.
So we can pull information from the Kubernetes cluster, and we can pull information also from some data sources. These have to be, we have a list of supported ones, as I was saying before, SIG-store, registries, DNS lookups, but the list is limited. We can expand it, but you can't query anything. It has to be on this list.
I mean, correct me if I'm wrong, Flavio, but at the end of the day, for Kubewarden, you just write code in whichever language you chose. That code can do whatever you want it to do as long as it responds back, right?
Not really, because as I was saying before, everything is sandboxed. So for security reason, we only allow certain operation to be done. And on top of that, WebAssembly by definition is pretty limited in what can be done, like networking requests cannot be opened. Well, there is some work being done in this space, but we prefer to keep things shut for security reasons, and then offer access through the SDKs that we offer through the different languages.
And we have one more question. It's for Flavio. It says, can I run several policy servers in Kubewarden? Which I don't know. I'll let you. Maybe don't quite understand the question.
Yeah, the policy server is the component that I was mentioning before, the one where policies are actually run. And so this is defined through a CRD. So through the CRD, you can define multiple instances of it. And then you can decide which policies are run on which policy server. And maybe you have like a policy server reserved to run special policies that have high availability requirements or that have to serve tenants with a lot of traffic.
Wonderful. And that wraps up all of our questions. Thanks, audience. Thanks, chat, for asking such great questions. Oh, it's need to hide it. There we go. So we're gonna wrap this up. We're gonna wrap this up by everyone gets to say a closing statement. We'll say goodbye in the order we gave our talks. So
and everybody watching, don't go away. We are yet to put the link to the voting.
Yes, we need to give you a voting link, and I'm going to put it live right now. There's a lot of buttons. Anyway, so Tim, will you please take 30 seconds tops and give an overview of why validating admission policy is good?
Validating admission policies are going to be available in every Kubernetes cluster. You'll always be able to rely on them being available. You won't have to install anything. Once it's genuinely available, they will just be there.
Awesome. They're going to be around, so get used to them. All right. Bye, Tim. Thank you so much. All right. Kevin, you were next, yes?
I was. Cloud Custodian is mature. Cloud Custodian is simple to configure, and Cloud Custodian can be used on way more than just your Kubernetes policies, but it's incredibly powerful for doing that too.
Wonderful. Thank you so much. Enjoy your chickens and your podcast. We'll see you later, Kevin.
See you later.
Bye. Oh, and then Rita. Oops.
Gatekeeper can be that front-end abstraction layer that helps you provide multi-language, multi-engine, multi-target policy enforcement at scale to allow for portable policies, coexistence of numerous policy implementations, allowing your users to write policy once in the language of their choice, and they can run anywhere.
Awesome. That's fantastic. Thank you, Rita, for sharing your time today. Bye. Jim.
Yeah, so Kyverno was designed for Kubernetes admins, for platform teams trying to provide secure self-service. And we look at that complete life cycle, right? So besides just, defining policies, it's about self-service for reporting, self-service for managing exceptions. And it's exciting to see the project evolve to fulfill that mission.
Super cool. Thank you, Jim. And Flavio, last but not least.
Yeah, so Kubewarden allows policy authors to write policies using the languages they're more familiar with, for using the tools and knowledge that they already have. And for operators, it allows them to reuse policies made by others. Like, they're pulling container images made by other people they trust. They can reuse policies made by other people that are trusted.
Amazing. Thank you, Flavio.
Bye-bye.
And then there were two. We have a question. Can we vote for validating admission policy and something else? No, you can only vote for one thing. Sorry. And we also have a thanks for the presentations, which I +1. Thank you so much to our presenters. And then the link. It's time to vote. So tell us what you think about the new voting spot. This link is going to take you to the CNCF Slack, to a You Choose Slack channel where we've published a poll that will that we're going to use to decide which technology gets implemented into our ongoing demo. The poll will be up for 3 days, but don't let that stop you from voting right now.
And the link is in the description. So if you don't like, pausing the video to figure out all the letters, I consider it I made it easier than it was. Huh? You should have seen the link that Whitney sent me. Anyways, the link is in the description. It's in the comments as well. Vote.
Yes, it's everywhere. Yes, votes. Thank you so much. And this is super fun. And we can't wait to see you next week. Next week, we're going to talk about runtime policy. We have someone on from Falco and someone on from Kubearmor. So we'll be talking about that.
And we already scheduled the video, so it's already in the channel. You can already right now click that button to be notified. Next week, same day, same time.
Yeah. See you then. Bye.
Yeah.